Okay, hi everyone. Welcome to another design review about arrays. And I guess this is our fifth meeting in this series. And we're going to start off today reviewing backend storage technology for arrays. Is that correct?
Yes.
Okay, where should we start?
Okay,
so
should we survey the ones that we're going to remove from our discussion just to make sure we're all on the same page? The existing models with good story and Wolfram language?
Yeah, we thought that probably these things, they are already represented quite well within Wolfram language.
Okay, well, I mean, the in-core versions are. Right, the in-core version of these is.
Yeah, sure.
Yes, in-core, sure.
I mean, like a sparse array, one could imagine having some out-of-core manifestation, but we're not discussing that right now.
Yeah.
Okay, all right. Okay, you guys are in charge. What's next? Do you want to share your screen? Or?
No, I mean, we can look at this document on your screen if you want, but basically the idea is that first you have storage technology divided by basically the shape the data takes. So document-based are things like Mongo. Tabular is everything from relational databases to data frames, all sorts of stuff like that. Triple stores are RDF, so Sparkle, and key values are things like Redis and company.
Oh, yeah. What about graph stores, for example?
Graph stores are triple stores.
Yeah, actually, before we go, one important thing here is that when we looked at that flat list that we inherited from the previous meeting, the big problem with that list was that it wasn't properly classified according to certain, properties. And so we've picked several, which are storage technology, storage form, if you scroll slightly down, then what we call computational model, which is distinct from storage technology, which is more about the APIs and query languages, and the degree of integration with Wolfram language. So all backends which are listed here, we tried to categorize according to this for properties.
Okay, so let me understand. When you say storage technology, in some sense, you mean how do you reference an element in the store?
And to give an example, the distinction between storage technology and computational model is that, for example, you can use Sparkle to query something that is not necessarily a graph, but there is a translation layer from Sparkle to SQL. And so you can query with Sparkle a traditional SQL database. And that is also true of most OLAP implementations. So in a sense, the computational model is like the API you use for querying, while the storage technology is how they're stored on disk or whatever, server or in memory.
Okay.
What shape the data takes.
Okay. Well, and I understand those storage forms, although I don't quite understand. I mean, server and cloud do you mean a database? Because there can be files in the cloud. What do you mean by that?
It means that it's abstracted. Like, it means that, of course, in the end, the database, when you drill down, it's more or less going to be implemented through files. But you're not accessing it as a file. You're not opening, you're not importing. You're accessing it differently.
Or you don't have an actual file handle in the OS sense. You have some abstracted API, I presume, is what you're getting at. So you have streaming API as opposed to the traditional file handle API or something like that.
But what about, I'm sorry, what about a more of a RESTful API as opposed to, you said streaming API. That's different.
Yeah, but this is more about the computational model and the storage form.
No. We're talking about storage form right now.
I think what we had in mind was to classify according to how sort of close it is to the process where the kernel process, like in memory is the closest, files is still local, not over the network, but still on the OS, and everything else is network.
Yeah, but I mean, in a sense, like when we're talking like databases,
sometimes can sidestep files themselves. Like they have a special relationship with the file system, right? So they don't act as files for the US.
Yeah,
so
they usually do block level storage. They don't
Yeah.
do files. But the API, the computational model, usually you decide what are the ways to access it. And there are certain primitives that you make very fast. And then you decompose everything in terms of those. So that's SQL has a very little language, which syntactically is made a little bit bigger in the published.
I don't understand why you're saying data frame is part of table-based. I mean, it's not the same as, what do you mean by table? Do you mean two-dimensional or you mean something different?
Yeah, pretty much two-dimensional.
Okay, then why is data frame part of that?
Because data frames, most data frames are two-dimensional.
Okay, but we already discussed how we want to make something.
I'm not saying our data frame is going to be. I'm talking ours data frame, Panda's data frame, and so on. RO and whatnot. So when people talk about the
okay. What are we trying to achieve with this list?
Well, there are a number of backends that we wanted to classify according to what kind of where they are in this space. And if you look at the data set below, it contains those backends. So we tried to find some orthogonal properties to use this classification. That's what we came up with.
Okay, all right. But I mean, look, the bottom line here is we're going to be implementing certain things. So we can classify as much as we want, but in the end, we're going to be implementing certain things. So hopefully this is contributing to that.
Well, yes, but we did exactly as you requested us for that list. That's what we've done.
Okay. All right. Okay. All right. Well, let's. What was the thing? I'm sorry. You have to remind me. These are technologies.
Yes.
I see.
So these are either database server-based or otherwise database engines, which are widely used, or some of them are distributed or used for big data. Some of them are, I mean, this is reasonably representative list of technologies that uses out of core data and queries them.
Okay. So, and some of these are things we use right now or have links to right now. Some we do not.
Yes.
And you're going to make some proposal.
The last column tells us that.
Yeah, you can look at basically integration level. There are some links that we
have.
Okay,
I get it.
What's the difference between research and prototype?
Well, I made up this list, but basically research means that some work has been done, but nothing of I was at least aware of was in a shape where we could say that something is actually working to the extent that we can say, okay, this is kind of a prototype. While for Redis, for instance, we know that it was used internally for cloud expression. So I inserted prototype here as a sign that it was actually used. So probably we have something working.
Okay.
Okay.
Is there a proposal here for what we should do?
Well, I think there might be multiple proposals here. Like for sure, one thing that comes out of this is that the tabular space is very rich. And there are many approaches that tend to bridge several versions of this together. While as far as we could tell, much of the, trying to have hierarchical data or document-based and tabular live together have mostly failed.
Okay.
What is OLAP for those of us who are not expert in databases?
So OLAP is more of a multidimensional way of looking at data.
What does it stand for?
Online analytical processing.
What's that?
Online analytical processing.
Really? I didn't know that's what it's for. Okay.
This is basically a case where you have lots and lots of data that form some kind of multidimensional grid of sorts, and which you want to analyze by taking certain sections and computing certain aggregations on those sections.
Yeah, people talk about OLAP cubes, which are usually
Okay. So this is related to a thing we long studied, which is the question of if you have a huge amount of weather data, for let's say, and you want to be able to compute certain short queries quickly, like the average temperature in a month, as opposed to the average temperature from the 21st of the month at 2 p.m., blah, 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 to whatever. There is, this is this data summarization, data hierarchical, data summarization type thing. Is that correct?
It doesn't have to be hierarchical, but it can be multidimensional.
No, but I understand. But the purpose of it is to be able to do things. For us, would be to be able to do things like, given a large amount of data, be able to cache the results for the mean of this slice of the data. Am I making sense?
One of the possible things, yes.
I'm confused. Okay, what is it useful for to us? This kind of approach. The thing I just described or something different? I don't just want the general marketing pitch for OLAP. I've heard that a million times.
Well, I don't think it is the most useful thing here. I mean, it's kind of falling out of fashion in favor of a more data framey approach. I think
it's solving a different problem. That's solving a different problem, right? The data frame problem is solving the problem, as we discussed previously, of you have data stored in some efficient format, and we're talking about a few different formats for that, but it is some dense, structured format. On the outside, you want to access the data through certain, part specifications, and you want to wrap the data through with units or missing stuff or whatever else. That's
I'm not talking about our scaffolded array. I'm talking about what kind of APIs people who do.
No, I understand, but I'm trying to clarify what it is that's useful about these things. Okay, and the thing we've described there is element at a time, getting the element you want, getting it in the right form. Am I making sense? That's what this data frame thing is specifically. That's what that would achieve for us. Am I right?
I would disagree on one element at a time, in that data frame makes it very natural to work with, say, a column at a time, whatever column means here. But
okay. So then the thing that we need to think about is, if it is a column at a time, there is a question: are you just getting the raw data, or are you getting some aggregation of that column? You understand what I'm saying?
Yeah, it depends, but
it doesn't depend. It's the whole point is we're trying to look.
No, it depends on whether you're performing an aggregation or not. But the point is that the cool thing about data frame for us is like it's listable by default. Basically, it's listable first, and that's where it ties in with the other discussion on arrays, that threaded and so on.
Well, okay, hold on a second. I think I need to go back to my previous notes. Okay, so what did this come from specifically? What part of this were you trying to add to?
There was the list of backends that use and technologies here. You see general technologies in backends where you started to build this list, and then.
Okay, so where's HDF on your list?
Oh, actually, HDF is missing.
Great.
Yeah, that's my fault, because I
where's CSV on your list?
Well,
CSV is more a format. It's
well, HDF is a format as well.
But HDF contains a rather rich API, which makes it a little bit more than just a format. CSV is mostly just.
Put it another way, people don't usually work with CSV on the CSV file. They import it in some way, and then they can serialize back to CSV, but you don't actively work on the CSV.
Okay, so the thing that we did not describe here, okay, is we didn't describe it. The OLAP case that we did not describe is something where there is the result of some partial operation already stored in the data container. Am I making sense? Okay, look. The end result of these meetings cannot be an infinite series of meetings. The point of these meetings is to come up with a small number of things that we are then going to implement, of which data container, scaffolded array, whatever it's called, is definitely one of them. Do we agree?
Absolutely.
Okay, so let's just write down what we know we're going to do. Okay.
I was just trying to parse what you just said about storing the result, what that means actually.
Okay, well, so the one thing we have here, we know we're going to have data container, whatever it's called, right? Data container, and now data container, the API, what does the API look like? The API has these, basically, I guess it's like the CRUD interface. Well, no, that's read-write. The data container is at first a read-only, initially read-only. Is that correct? See, the thing is, okay, listen, guys. The thing we have to do here, we're not just going to do an infinite series of meetings. We are going to do a design and implement the design. And I'm concerned that what you've got here is not moving us towards that. It's just a circling, if I'm making sense.
Yeah, I mean.
Okay, so tell me what we learned from what you've got here that helps us move towards a design, rather than just circling around, which I'm not that interested in.
I think that one of the most interesting examples of this that we found while looking at this is what they've been trying to do in which is especially interesting because it comes from a similar functional programming language, is if you click on tables.jl integrations in Julia, under Julia, integration is a link.
The first bullet point.
First bullet point, integrations is a link.
Okay. So we can't figure it out for ourselves, so we're just going to look at what somebody else has done.
No, what I
come on, we can do better here.
I'm just saying that what is impressive here is that by restricting to tables, so 2D things, they are able to do all those integrations, which include CSV, include SQL, etc. So they're all different. It's like all of these are open source projects. So some are high quality, some are just experimental, of course, but they share the same API, which is just
great spelling mistake. Brilliant.
Yeah, of course.
Crap. Come on, guys. Come on. Have you gone through this and figured out if there's anything actually reasonable here? Or are we just going to see a bunch of spelling mistakes?
Yeah, the interface, what they decided is the common API is reasonable. Then
is there documentation for the, yeah.
Where is the common API?
Line below interface is another link. So basically, if you implement 5 of these, you can subscribe to the model.
Okay.
So
okay, well, these are kind of obvious things, right? What is Materializer?
But see, I mean, Materializer is the most interesting thing because it's the thing that allows you to transform from one another. And so you basically take a CSV file and allows you to import it and maybe move it directly into SQLite. That's what it does.
Okay.
It's a sync function.
Okay. Okay, great. All right. Well, maybe you guys can study that in more detail. I think that's not the most interesting thing for us. Can we actually get to, okay, what else do we learn from this, or should we just go back to what we were doing before? What else do we learn from what you've done here? Well, I don't understand what we learned. We had specific objectives last time. We're trying to move towards those objectives. We're not circling around making a giant study.
So what I was trying to say is that for me, the thing that is clear about this is that there is definitely a lot of common ground in everything that is rectangularish 2D. And those can share an API. There's a bunch of things a bunch of projects that allow you to say, write some kind of generic SQL to query things that are not relational databases, because in the end, they're all transformations in this space of 2D structures. So I think that would be the first place where I put our weight like trying to understand the 2D case very well.
And let me add that as far as 2D constructs, our tabular data import-export support, CSV, TSV, Excel, we have some common API as far as common elements and so forth in there already, which is pretty solid. It doesn't go beyond formats, obviously, but as far as we are talking about formats, that's there, that's solid.
Okay, so I don't understand what. Look, we already have a concept. It's called Dataset. It's working quite well. You're proposing what I thought we were trying to do before we went off track here is we're trying to make something which is like Dataset. It's a column-oriented thing. It's an efficient storage mechanism for lists of associations and so on. That's a thing we need to achieve. I'm not really that interested in going off on a giant exploration of everybody else's random.
No, it's
Well,
not.
hold on. Last time we talked about having more specific backends that were more restrictive, and then we were going to package those up in some way that was going to be more general.
Fine.
Right. And so one of the questions was, what more specific backends, are worth having, and how would those fit in with some more general thing that would incorporate several of these together?
Stephen,
Yes.
did you mean to say that Dataset is column oriented? Because I disagree.
No, it's not column oriented. That's the whole point. What I'm saying is the thing we know we need to do, which we already talked about, is whether it's through this data container thing, we need something which will take lists of associations, associations of associations, hierarchical collections of lists and associations.
No, that's what we learned, more or less, is that if you want to take lists of associations, associational association, random hierarchical stuff, n levels deep, you lost. That the really cool stuff stays within the 2D realm.
I don't believe you. I don't believe
I think that's a very common
I just don't believe
case
you.
still.
I know it's a common
Yes.
case. It's the case that's been being done since the 1960s. It's the case that's been being done probably since the original Hollerith card sorter.
And I think one thing we should
look,
improve is
Right.
definitely to improve this very common
Right.
case.
So what we
but not
need is a
limited to that.
design that
But
works.
isn't Dataset our arbitrary hierarchical viewer, right? I mean,
Yes, but it isn't efficient because it doesn't have the thing that we need that we already discussed about 6 times, or actually probably at least 4 times because of the 5th meeting in the series. The thing that we know we need is an efficient storage mechanism for nested collections of lists and associations, where we're not restoring the keys of the association for every element, and where the thing is basically not ragged. We don't worry about the ragged case. We know we already talked about this. We already talked about if it's small fraction ragged, small fraction missing. We have various kinds of ways to handle that. That's the thing we need to handle. Now, other people have worked on the 2-dimensional case at length. We should certainly learn from what they've done. We should not restrict it. Maybe we have a special efficiency hack for the 2-dimensional case, but the path that we were on, which is the one we should be following, is one where we make efficient, because I don't think it's going to be more difficult to do that than these other things. We make much more efficient the arbitrary depth, ragged list association hierarchical thing. No, I'm sorry, non-ragged version of this. Does that make sense?
Yes, and I think it's easy, Stephen. It's actually mappable to the 2D case.
May very well be.
Yeah, it is.
In some way other than the way Fortran does it?
No, I mean, it's mappable to 2D case like our packed arrays are. I mean, we represent the dimensions in some way that includes keys when they should have included. And then if we require dimensions to work, which it already does for array, but we represent keys instead of numbers, then you can do this.
Okay, so just so I understand, the number one thing that we want to do is we want to have something where there's essentially some kind of transducer, some translator, address translation unit that goes from which is what we discussed last time and the time before, which goes from the part number you request, which might be a list part or an association key, some sequence of those things to actually extract the element you need. Then there's the question of how much can you do all together with a particular column, row, other slice. Am I making sense?
Yep.
Okay, so
And I have a prototype of that.
Okay.
It's very crude, but
do you
I
want to
think
show it to us?
So think what
well,
both
I don't
Rob,
want to show it to you at this point, but I could maybe in the next meeting, some
Yeah.
discussion,
Okay.
say.
what one thing which we discussed already in the first meeting is that both Jose and Rob has arrived at is that you can have different types in the last dimension only. But that mirrors this fact that it's basically a 2D case where the last dimension are the columns.
Okay. So what you're saying is, I mean, the way that you're describing that is the list of indices, you're describing that as it doesn't matter that the prefix indices are an outer product.
Right.
Is that correct?
Correct. Yes, that's exactly it.
Okay.
Yeah. And clearly we can have a container that can happily mix keys and numbers.
Yes.
That's what I'm saying. The association and
Right.
list.
Okay. So So I think we're brilliant that we're agreeing on this part of it.
Mhm.
Okay. Now, the question that I wanted to understand. So some of the issues there are what to do with missings, what to do with small amounts of raggedness, and what
So-
I'm assuming.
Right. Hold on. Just to give a few answers along the way.
Mhm.
We have to represent missing. Without at least minimally, we need to represent that it is missing in an efficient way.
Mhm.
And some of these backends do that. I think several of them do it actually.
Almost all.
Okay.
Yeah.
Fine.
Mhm.
And then,
Out
but
of
then there's another
curiosity-
layer of what to do. I think that's needed for workflows, but the core storage technology is probably not going to do that.
Right.
Do you mean sort of the algebra of missing, that 2 plus missing is also missing or something like that?
Well,
Not necessarily.
I
that
mean, I
exact
think I
case,
don't know
but-
that the storage technology implements an algebra particularly.
No,
Do
it
they?
doesn't.
No, sure, but we
Mm.
kind of, I mean, this is something that sort of has come up many times before, right? Which is that, if you have a big list with some missings in it, you try and do any kind of, if you do mean of a list that contains a missing, you get back this sort of algebraic gunk, right?
Oh, I see what you're saying. No, I mean, we need to clearly work on the workflows. And so there are at least two ways of doing it. There could be a sort of an algebra that it poisons everything. But there's also the thing of filling in missing with different methods. And there are a bunch of different methods.
Yes.
You
Right.
know,
We've
Right.
got that. I mean, we got synthesize.
Yeah, but this need to work at sort of scale and
Right.
Yeah,
Right.
I mean,
There's
a
things
lot
like-
of these, like to give the simplest example is SQL, which also has the right computational model for the sticky missings, and you can set defaults from where you want to like fill in the missings as well. So a lot of these servers will do it for you.
Whatever. I mean, okay. So this is a separate thing, the algebra of missing and these different operations that you might do. And I mean, I think one could imagine a situation in which there's something called, missing function or something, which says what to do with a missing, which has these various actions to take when you run into a missing, when you're doing certain kinds of operations.
I think there might already be a missing function in time series or something like that.
yes.
Yeah. Which deals with almost exactly this issue of what do you fill it in, what do you fill in missings with?
I think it's called missing handler, maybe not missing function. Is it missing function or missing handler?
There's missing behavior as well for query.
Missing data method, maybe?
Okay. So
Right. Well, actually, by the way, maybe one other question that's kind of related is how do most of these systems represent missings, in these sort of packed forms? I mean, do they just use some, IEEE NaN kind of thing, or do they have something more sophisticated?
It depends, but in most cases, null is separate from NaN.
Okay, but it's just some special, if you have a packed array of floats, let's say, it's just some special, float or something that represents missing. I'm wondering basically, like, can you have, because for us with missing, our missings can have parameters and stuff like that, which kind of makes it a little more complicated because it's not just missing, it's missing, and this is the reason, and this is the expr, and so on.
Yeah,
so I'm wondering
usually, like, I think most of these backends implement missing that's separate from not a number, but you can't attach metadata to why it's missing. It's just
you cannot.
I think we could do
usually
something like
no.
that by
Usually
having a
no.
lookup.
Having a lookup, yeah, okay.
So we might say that the floating point number, 10 to the minus 300th, for example, is represents a missing. And then when we hit that number, we look up and see if that's in the missing table.
Exactly. Right. Exactly.
And,
I think that's
so we could have a number of different missings, which would have different tokens, different types of missing.
Right.
And if it's not in the missing table, then we treat it as that number.
Okay, and is it okay? Right, and so then there isn't a risk of numbers mysteriously turning into missing.
That removes
numbers going missing.
Yeah.
Guys, that won't work with existing out of core solutions. Like that, you're gonna have one type of missing only then, because otherwise you don't get the efficiency.
What are you talking about? What are you talking about? What we're interested in is that's only relevant if you're doing operations out of core, right?
Can I interject that, we keep talking about efficiency, but we're not very clear about what kind of efficiency. So Stephen, I think you're really focused on space efficiency because you don't want to duplicate keys and whatnot.
Mm-hmm.
And that's going to come at a cost of, various slice efficiencies or, algorithmic time efficiency.
Well, I don't know. I mean, I think that there's sometimes, I think, for example, the thing that Rob is talking about would almost certainly, I mean, with a little bit of work, could almost certainly come with lots of time efficiency stuff, because fundamentally it's just about
for certain slices. Right.
Okay. The question is this. The question is this, guys. In terms of time efficiency, the problem is, what if your slice isn't a contiguous slice? What if you want a non-contiguous slice? Right?
Yeah, what do you mean by contiguous?
Well, I mean, in Rob's method, anything which has a given prefix index sequence, the thing you get out with a given prefix index sequence is going to be a thing that somehow you can just pick it up and do something with it. If, on the other hand, what you want is, in tensor notation, if what you wanted was something like, 1, 3, 4, I, 5, 3, I or something, you wanted to do a Einstein summation convention across those two indices, that would be difficult to do in Rob's scheme.
Well, I think if we keep this idea of rectangularish to be allowing raggedness only in the very last dimension, it wouldn't be as efficient, but it wouldn't be terrible.
Is that because Fortran-like there is a fixed stride that you go through?
Right, exactly. It gives us a fixed stride to work with. That's.
I mean, I don't know why are we talking about this? Like, when you say,
because we're trying to actually implement something, Carlo.
Yeah, but
that's why we're talking
about when you're taking a slice of a big data set, you don't care about strides and whatnot. You're filtering over some property, and if you redefine the missing to be some random float,
we're not talking about missing.
Do it on the server.
I think this is a level
and that
lower.
Breaks everything.
I think the stride thing is like in the implementation, you need to have stuff like that. Like, I think that the stride issue is a lower level than what you're talking about, I think.
Yeah, that's right, Christopher. It's an implementation level thing.
Right. And the problem with strides is you don't keep things in the cache if the stride is too big, among other things.
But the point, I mean, the thing that is potentially nice is that the storage would be, column oriented across the last dimension. So if you wanted to do stuff across columns, you'd have relatively efficient access.
Okay. But so what you're building, Rob, as I understand it, is this data container mechanism where there is efficient access to elements, where it is possible to get an efficient slice out.
Yeah.
I mean, okay, the things you can do presumably are extract an element or a slice, right, of some kind, where we define when you extract an element, okay, process, quantity, etc. wrapping. Well, extract an element, mapping from mapping keys appropriately. Right. Okay. Process, quantity, etc. Wrappers. In other words, return quantity, etc. wrappers as appropriate. E.g.
But by the way, though, I mean that one is also one that would be great for packed arrays.
I can't comment.
I mean, like, that one is just as useful. I mean, it's just as useful to have quantities in packed arrays as it is to have quantities in this thing.
Well, I think packed arrays should be kept packed arrays. We can put packed arrays into this thing as the underlying storage, and then you have it for packed arrays.
Okay, but could you have? I guess then you could have, as opposed to having a, if I had a big number of reals and there's a couple of missings in it, or a couple of, or if there are quantities associated with it, then your point is that the solution is not to have a packed array with quantities associated with it. The solution is just to have one of these,
Yes.
Okay, fine. Yeah,
right.
That makes
sense.
Then
when it returns quantity wrappers or geoposition, etc. wrappers, it will do so in some cases returning to top level something like a quantity array, rather than a list of quantity objects. If I request a slice.
But if you ask a column, probably yes. If you ask a row, then no.
Well, but also, I mean, I thought that part of the thing we were talking about was sort of having it so that it, I don't know. I mean, I don't know how transparent this thing is, right? I mean, is this a kind of a secret thing like packed array, or is this something where it's going to be very visible?
I think initially it might be visible, but I think it should go underwater eventually.
Well, I'm using Stephen's paradigm from last time or the time before, where we said we're going to start with it being visible and hopefully make it invisible at some point.
Okay, fine. But I'm just thinking about, I mean, so if it, because if it were invisible, or if we're thinking about the theoretical invisible phase, then then it might just look like a list of quantities and not like a quantity array.
Exactly. Yes,
right.
I agree, which is the way it should look in the end. I mean, we might want it to print differently and things like that. What should the print form, I mean, I don't actually know whether we've thought about this recently. What should the print form of a quantity array be? In other words, it could be that you'd actually want it to say 2, 3, 4 meters, not 2 meters, 3 meters, 4 meters. Am I making sense? Which again would improve some efficiency. Okay.
Yeah. Maybe one other question is, how is it?
Sorry, Christopher.
Go ahead. Go ahead.
Do we plan this solution with structure to also handle some operations? Like if you do, can you do log on a column? Can you do?
Well, that's the question. Okay, so let's come to that in a minute.
And I'm asking this now simply because together with missing, there's stuff like indeterminate and stuff like, because right now, we have stuff like unpacking, and this is a problem for like handling, big databases. You don't want to unpack a column of reals.
Let's talk about various things. Actually, there's a question on our live stream from Nick about ML Dataset, which is apparently, I don't even know how this works. Giulio, that's probably your area. The innards of the machine learning system. What is it using?
That's just a dataset in the end, but
what is the ML dataset? What is that?
Yeah, it's a different head. It's backed by dataset. It's just used to. I can give you a demo if you want next time.
But what's the point of it, and how does it relate to what we're talking about here?
The point is to whenever you throw rows at functions like classify, for example, like rows because you give an array with a temperature, a number, a boolean, and then we store it in a column-oriented way internally. And given that dataset is not column-oriented, there's a little API around it to
I see.
basically
So
just
once
do path
data
extraction,
container,
sampling, stuff like that.
right. So once data container exists, you would expect to, or whatever it's going to be called, you would expect to use it for that purpose.
Oh yeah. I'm just waiting for this to be real and switch to that.
Okay, fine. Okay, Christopher, did you have something? And then I want to talk about operations within data container.
Well, this is kind of related to operations, but I guess the question is how we deal with effectively packing and unpacking. So, for example, if I can imagine there are lots of ways that you would end up with a list of quantities, and the question is how you would know, or maybe how you could even request that this be kind of packaged up, if you know what I mean.
Right, because it's like import elements. It's like, should it end up as a quantity array or should it end up as something else? And in the end, it's not going to matter because it's all going to be invisible.
Hopefully, yes. But it's like the issue we talked about the other day about last time about if you map over a packed array, how does it know whether the result is packed or not?
Well,
you could assume that it always is, and if it cannot pack it, it just replace your garbage with something that packs. Which maybe, most of the time is what you want if you care about the integrity of your.
I guess the point here, though, is that this is a little more flexible, where there are lots and lots of different things that might return something that could be, in a format that can be data containerized or whatever the term is, right? So I don't know. Maybe it's like packed arrays where there are certain functions that realize that their outputs, they need to check if their outputs can be packed. But then a lot of other functions will just not, and maybe that's the way to do it. But
well, I think fundamentally, I think for like easiness, so I'm talking about my use here and probably many other people. I would like this to be with some opt-in or opt-out mechanism, which you don't have right now in packed arrays, yeah. Because sometimes you do care about storing whatever you have, whatever you have returned, and that's important. Some other times it's less important, and you don't want to sacrifice it.
And I guess that's the thing we were also talking about, which maybe would be nice to have for packed arrays too, about having a head, right? So if you use the head, where it's, if you use the visible form, then you're guaranteed that it's using it. But of course, if you're using the invisible form, then the guarantees are kind of out the window. But I guess I'm just asking about in the invisible case, which maybe we shouldn't think too much about right now because that's sort of in the future. But in the invisible case, how it basically deals with the same issue that packed array deals with of figuring out when to pack and when it can't pack.
Right. So, okay, let's talk about, all right, so some of these operations are just extraction operations. Now the question is, what if you want something aggregated? What if you want a selector function running within the data container? Which depends on these things that were over here on the left of how actually is the innards of the data container stored. Okay, so Rob, what is your approach right now to the innards of the data container? The things you're building, are they in core innards?
Yeah, everything I'm trying to play with is in core. My concept, and this is a part I haven't done as a prototype yet, is to have, so you have, so the last dimension can be ragged, but basically you specify columns based on that. And that could be, say, a column of images or a column of integers. So we could have types and quantities across the last dimension. And so everything will access stuff. So those columns could be, presumably extended to these out of core things. And maybe there's a better way to do that. But that's a possibility with this.
Well, so wait a minute. So what you're suggesting is that the higher levels, the prefix indices, are in core indices, but then the final payload at the lowest level is something that could be out of core. Is that what you're saying?
Yeah, I think so.
Okay, so let's review how that relates to, as I understand it, like the Mongo style databases, that is exactly what they would deal with. They have a bunch of metadata that is kind of in core-ish metadata, and then they have some big payload underneath. Or maybe can somebody comment on that, please?
Well,
am I right?
That payload is typically a file or something. What Rob was talking about is that you might have actually a database in place of a leaves. Am I right, Rob? I'm not sure if I got your proposal?
It could be a database. Yeah, I think that's certainly a possibility.
My only concern is this in core structure that we have scalable, and how much? Like, can it scale up to tens of millions of entries efficiently?
Well,
if it stays in core.
I think it potentially could. It depends. I mean, I guess one question is how many different tabular columns do you typically expect? I'm assuming there's not going to be, millions and millions of different.
Absolutely, there could be millions of columns. Absolutely. Don't even.
Oh, no, millions of columns, yeah. Not rows.
That's correct. There could be millions of columns, just as there could be millions of rows. We have no guarantee that people are going to store their data. I mean, the columns could be, you're thinking that the columns are, height, weight, and something or other, and hair color or something. But I'm thinking about columns that are in some, graph representation of something. They are the output from, case 1, 2, 3, 4, 5, 6, 7, 8, up to 1 million. Right. See what I'm saying? Yeah. There's absolutely nothing that says that the number of columns is small.
Yeah, fine. So the ideas I have might not work so well for that. I mean, it's still probably possible, but probably less effective.
Okay, but so I'm trying to understand, and again, this relates to the things we have on the left. Okay, for SQL, that is basically a two-dimensional tabular thing. That's essentially the outer product of rows and columns. So can we comment there? I mean, I don't think a typical SQL database doesn't really care whether the large number of things is in the rows or in the columns or in both of them, so long as it's not two spots.
No, you can't have a lot of columns. There's a limit, I think, on the number of columns. It's like 30 in a lot of databases.
Really?
Yeah.
Right.
I mean, it depends.
We can internally switch to have row-based stuff if we needed to, but again, we lose the effectiveness of having types across columns, which I think is kind of a key thing we're talking about.
All right. So in your model, Rob, the row index is the final index, is the one that is after all of the prefix, things. Yeah. See, this is the point. The point is what's needed for this data container is what you're basically saying is pick an index that's going to be a lot of it. Mm-hmm. You can deal with any of those. You just transpose the thing, right?
Sure. Right.
If you have two indices where there are lots of them, well, that's going to be the square of the number of elements, and it's, could be ridiculous. But in general, you're saying we're not handling that at this time. Is that correct? We're handling the case where the data container has one index that gets big, that gets
which, to be fair, it's a very, very common case that a lot of people will be happy if you can provide something.
I agree. I agree. It's a very common case, right? And we're giving some additional flexibility by the fact that our translator, our address translator, doesn't really care which, can deal with the transpositions needed to have that index appear naturally wherever it feels like appearing. Am I making sense?
I think a key question is where do types and units appear?
At the well, they appear.
I think at the bottom.
Yeah.
In the end, it's at the bottom, right?
So if you have 1 million columns, you have 1 million different units.
No.
Well, think of what quantity array does is, I think it has most of the time you have a single unit.
No, but I think Rob is saying unit stays on the short axis, not on the long axis.
Yeah, and units is a good could be 1 million strings, columns, some dates, some strings, some numbers, some.
You know what? That's not the case we care about.
Why not?
I
think we only care about the case we can already do well, which is numbers.
No. The thing we care about is fairly uniform data, right?
Yeah, but if you're talking about a list of strings is what he's talking about. I think that's something that we probably do want to.
We do want to care about. Yes, we do care about that. But I just want to clarify: The whole point is we've got a sequence of indices here that, and with those indices are, okay, look, we got, what have we got? We've got the specifier, basically, element specifier for the data container. Okay, the first thing we've got is the list of indices.
Of row
Okay.
indices. Mm-hmm.
I'm sorry?
Of row indices.
No, I mean the list of indices. It's either integers or keys. Or
but those are row indices, not column indices.
I don't care what kind of indices they are.
Well, I think it might be many levels.
That's the question here.
It doesn't matter. The whole point is, okay, there's a list of indices, and okay, of which one can have large cardinality. Does that make sense? Do you understand what I'm saying?
Right. That's basically the one that's like, in SQL, you can have lots of rows, but not lots of columns. So here, exactly. This is deeper. There's one dimension in which you can have lots of stuff.
Right. And it could be the case that it's the top dimension, that the whole thing is a list of records, so to speak, where each record contains a, name, rank, and serial number, so to speak, if I'm making sense. Right? Or it could be that the big dimension is the last index.
But right? Actually, I mean, hold on a second. I mean, based on Rob's description of how this works, it doesn't sound like you're really restricted to have one big dimension, exactly. Right? Like maybe the bottom dimension can't be big. Yeah.
All but one can have large cardinality.
And that but one is the bottom. It's like the yes, row exactly. One. Yeah.
No, wait a minute. It's not the row. The row can have. What do you mean the row?
So the point is, if you can have any number of any cardinality for all the indices except the bottom where you have height, width, height, weight, whatever. Right.
I see. Okay. That's a different way of explaining it. But then okay. So then somebody has background noise, by the way. Okay. Then for the short dimension, there are also types associated. Is that right?
Yeah.
And by the way, I mean, right, types and also
quantity wrappers, like,
yeah,
etc. associated. And now, when the missings come in, do they come only? They come. Where do they go? The missings can either go into one entry of the short dimension, or they can presumably go higher level. There can be a missing. Is that true?
I mean, you can have a whole row. Not really, because the indices are columns as well, really. If you think about it, like right. The record and rank and so on, you can consider them indices.
There's a lot of stuff we can have there at the bottom, like dates too, Stephen. Like position, geo positions and dates, the stuff that has additional administrative information to tell about itself.
Yes. Okay. So okay, at the bottom level, at the short level, whatever we call it, there could be any template, any repeated templates.
Well, right. But is it? I'm not sure. Is it if it's? I mean, maybe this is an implementation question, but it's not clear whether it's any repeated template or whether it's really, some set of types that we have efficient representations of.
Well, but what I think it is.
No, but like dates and geopositions, they store things like geoellipsoid, a lot of extra stuff.
Exactly.
No, sure. Right.
But you only need to store it once.
I'm just kind of saying an implementation thing. I mean, one version would be we have some general. I mean, we talked about this before, and it sounds like structured array maybe does a little bit of this as well, where you have some super general thing where you can have any sort of expression packaging of the data. But another version would be that for data objects, for geopositions, for quantities, we have some, probably related to the compiler or something, some compiled representation of that type, and it gets, represented in that way, if
Sure.
that makes sense.
Yeah.
Yeah. Okay.
But you see, the reason that this can scale and be efficient is that there's some form of uniformity that gets captured.
Yeah, right.
Right. But yeah, I'm just saying though that so basically there'll be certain shapes of expressions like data objects or quantities or whatever, which will have specific kind of efficient representations of, where they'll internally basically be structs, and then you can pack those and they'll be uniform and everything. So yeah, okay.
In particular, could they be compiled expressions?
If you mean yes, like if you're talking about the compiled expression declaration thing, yes, and I think it sounds like that's basically what they are.
Right.
Yes, I think they potentially could, Christopher.
Okay.
Yeah.
All right. Okay. So now that we're talking about this, okay, so we understand what the structure is. Now the question is, how are we actually storing the lowest level thing? How are we storing the backend object that Rob has built? He's built the in-core version of this. Now the thing we want to talk about is what about the out-of-core versions? And then we come back to what kind of aggregation, selection, etc. functions can be supported directly within the data container, even if the back end of the data container is a remote server. Right? So what are the possible backends for this data container object?
Well, okay, what do you mean by backends though? Because do you mean backends and where's the data? Because here's maybe a more basic question, right? I mean, earlier when we first had the meeting one of this, a lot of what we were talking about was integrating things like some of these existing data frame library, Apache Spark and stuff like that. And now it sounds like we're much more talking about making our own thing. So maybe one naive question is, is there? Should we just go off and make our own thing, or should we also, in addition to making our own thing, try and integrate some Apache Spark or whatever it is for special cases? Because I don't know if for example, I don't know if those things are really super efficient and optimized, and they're more optimized than we'll be able to make. And so, we should use them in special cases.
I don't think we know, but we certainly know that databases.
But we have a use case. Okay, so we are using, I think, Arrow in an import export project. That allows us to bet a dramatic speed up of CSV, XLS, and etc. by ingesting it into that data container and then do things.
That's in memory, Arrow. So
right, okay. But the reason I bring this up though is because the reason I bring this up also is because it's like for example, a lot of the out of core stuff we were talking about before, we were doing out of core in the form of, okay, we're going to use some library, I don't know what they're called, for out of core stuff, and by integrating with that, we'll have out of core support. But it sort of sounds like, if we have this, like when you say backend, the question is backend mean Apache Arrow, or does it mean something that we make that's running on a server somewhere?
I think it could mean either of those two. I think it means
I think those are two very different definitions of the word backend. But yes,
well, I understand. But for example, Leonid's lazy lists is presumably something, particularly with this one deification that we've talked about. I would have thought his lazy lists would be directly usable for this.
I think it would be. I don't know, and I need to talk to Leonid whether it'd be more efficient to have one lazy list for each column, or one lazy list for the whole thing.
Yeah, I think lazy list at this point is more like an interface which has one particular implementation, which is in memory. So
it's not all in memory. It's
going
through memory, but its backend storage can be a file.
Yes, exactly. But what I'm saying is that it has one particular kind of, its model is somewhat more general than the implementation that currently exists. And so it can incorporate as file back storage, or even in memory storage, some chunks which are, for instance, Rob's constructs or something else. So, and on top of that, it will provide them the interface that allows to use familiar functions like map or whatnot.
Okay, hold on. I want to come back again to this question of Rob has a mechanism where he is storing in memory in an efficient way without replicating, association keys, all that kind of thing, our data container type stuff. Okay, let's now consider the case. It's a giant data container that has you know, a billion rows, each 50 columns wide or something, and we're storing all of this, but the operations we want to do are only going to sample some small piece of this. So we want to store those things in files. We never want them to be moved into memory. And then how do we do that? Right? So what is that backend storage? Is it a database? Is it a file? Is it something different? What are the possible backend storage things that we should consider?
So there are various, there are various techniques to do this.
Okay, what are they?
So the first one is that in general, if you're using a database and there is an important dimension which you usually sample.
I don't care about that. I understand that point.
Okay, well,
I'm asking much more basically. I'm asking much more basically. If we're doing this, right, what technologies are we supporting as the thing that can be, Rob is going to have this data container thing where, as far as the top level function is concerned, it's just a giant, data set like collection of lists and associations. The question is, what is there under the hood? Yeah. Am I making sense?
I mean, it sounds like there are probably many possible, out of core backends. Certainly, It sounds like you could use something like an SQL database, because I mean, basically, you just need, the only thing that you need to right. I mean, you just need to have the index, and then you have the columns, and then that's basically the same as how it's going to be represented internally anyway. So, yeah, I mean, it sounds like there are probably many different.
Well, but what are they? But let's talk about which ones we already support. Okay, one thing we already support is SQL databases. We should be able to use an SQL database as the backend. So, for example, a big question is, where did the data come from? Okay, you're dealing with a huge amount of data. Where did the data come from? Right? You didn't make it all. You didn't make that petabyte of data. Right? So where did it come from? It might be already in an SQL database. Right? It might be already in files.
I mean, I'm not sure you didn't make it. I mean, like, for example, I've had projects where I'm doing things like, like I had a project where I went through, I parsed all of Wikipedia and all of the history of Wikipedia, right? And that's like, okay, you get a bunch of zipped XML files and you iterate over them, and you have to be careful, you're not, you don't have it all in memory at once, but in the end, it's, like a terabyte or something. And so it's, I don't know. I mean, I rarely, at least for me, have I sort of had cases where I'm dealing with some massive data set and I got it as an SQL database. It's usually not that nice.
You made it by processing something else.
Right. I mean, and that's, by the way, a little bit related maybe to Leonid's stuff, where, I mean, I don't know exactly what work, we don't really have a workflow right now other than maybe Leonid's stuff for doing this. Because right now, the only way you can really do that is, you call read or something like that, or read list. And because you can't import the whole thing at once, but.
Right.
Yeah.
So, okay. But whether you made it and put it, what do you put it in after you've made it? Do you put it in MX files, or what do you put it in?
You mean for lazy list specifically?
No, I was asking Christopher what would be a reasonable thing to put?
Probably in my case, I mean, I didn't write this in Mathematica. I wrote it in Rust because I couldn't write it in Mathematica. So I put them in basically a bunch of MX files, effectively, the equivalent of a bunch of MX files.
Okay. But go ahead.
One thing I want to mention here is one big stumbling block for streaming for laserdisc was that the MX or WXF formats, they are not very well suited, because if you need only a part of what is in that data, you have to load the entire chunk in memory, even if it's a single chunk. So you don't overflow the memory. But if you need to, for instance, do an out of core sort or other things which involve many chunks, then you do a lot of work that you don't have to do, because you simply can't only import parts of the data.
I get it. I understand.
Yeah, and that's where this format that would allow you to only import parts, either based on Parquet or something else similar to that, will be very, very useful.
Okay, hold on. That's a new, different idea. right? So there's storing general expressions out of core, right?
Ultimately, yes.
No, right. So what we have to do that is we have WXF, we have MX files. Those are two known methods. What else do we have? How does Cloud Expression store things?
Postgres.
I'm sorry?
It's a Postgres database.
I thought it was okay. In the end, it's a Postgres database, but that's an example. I mean, an SQLite analog of that would be an example of a file type thing where you could get subpieces of it.
Yes, that's one of the possibilities.
Right. Okay. So the question is, an efficient storage scheme with part access, right? Because
exactly.
Right. Okay.
You mean file-based storage scheme? Yeah.
Yeah.
Right. So in other words, where you can do the analog of seek to that part and extract it.
Exactly.
Okay. Yeah. Has anybody talked to Dorian about whether there's any possibility of putting that into WXF?
Yeah, we talked about it with him a little bit, but I think the outcome of that conversation was that WXF has not been designed with this sort of efficiency in mind. It's kind of possible, but has been designed specifically for that.
Okay, fine. So in the world, what has been designed for
Parquet, Apache Parquet.
Okay. How does it work?
Well, it has certain specification of how you store different types and data on a byte level. And it's probably not the only format.
Okay, but so fundamentally what it's probably doing is it's defining a record size and then saying to get to part number blah, 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 you simply go and compute what byte offset you're going to go to. Is that correct?
I think so.
Okay.
But
doesn't sound very profound.
I wouldn't be surprised if they're slightly cleverer things. I mean, I know, for example, with I think with for example, the 7-zip like LZMA format for compression. I think I read somewhere they have a mechanism where you can sort of seek to the middle, and they have kind of stuff for this. So I wouldn't be surprised if there are
All right, so let's go find this out, and let's go see what it would take to have something where the fundamental encoding is where it's something like a framed WXF, by which I mean something where, when the WXF is storing lots of identical elements, it is rigidly framed in such a way that you can, I don't know whether WXF can have filler bytes in it. If it can, then this is probably rather straightforward. Am I making sense?
I mean, it seems like it would almost.
The front end has a different idea, which is that it basically computes a little map, the cache, that says where things are.
Right. Well, and I mean, basically, this could be, so we need, again, an address translation function, which could be a pure, basically record size times, times index, or it could be more sophisticated.
Right. I mean, there could be something like, kind of like what I think Roger was saying. You could have something where, like with notebooks, where maybe there's an index and you can get yourself within 1,000 entries of your target, and then you search from there. But I mean, again, this seems like the sort of thing where there must be, maybe this Apache thing that Lena was talking about. There must be, theoretical computer science things for this.
But one thing I want to mention here is that one complication is that you want to maintain kind of packed form, and at the same time it's making things more complex, because if you want to save on memory and on speed of querying big chunks of these things at the same time, you want some form of packing. On the other hand, if their records are reasonably complex, you have to reconcile this packing with the complexity of those records.
Well, okay, fine. But I mean, the obvious thing would be to store compiled expressions at the bottom level. Either WXF or compiled expressions at the bottom level.
Well, I mean, that's basically, we don't, I mean, okay. Right now we don't have a serialization mechanism for basically compiled structs, but it's probably not, I don't know how hard that is.
Why do you say compiled expressions? Because that doesn't seem very uniform in size.
Well, no, I compile, I mean, this is just, if you have a type in the compiler, I mean, ultimately it'll be like a struct or something. So it will be, it'll always be the same size, right?
Oh, so you don't mean general expressions because, you know,
No.
it's like, no,
Yes.
okay, okay.
No. But I mean, I would imagine that the main thing is a framed WXF where, okay, but all of these things are kind of, let's talk about aggregation functions and selection functions. Okay, I want to pull out of my data container those elements where the third string has a Q in it or something. What do I do, and how much of that can be compiled into something that is, for example, I mean, we've gone to a lot of trouble recently to compile a bunch of stuff into SQL, right? Mm-hmm. So, for example, if we were representing the long index, so to speak, or the non-short indices, if this was represented as rows in an SQL system, then we could imagine, I mean, these operations within a data set are looking at the payload data and doing things based on it, as opposed to what we've been discussing so far, which is just looking at the indices. Am I making sense?
Yeah.
Right. So now the question is, when we look at the payload data, how do we do it, and how does that work in these different implementations? For example, go ahead.
Yeah, that depends on what the payload data looks like, because if it is things like numbers or strings or dates, whatnot, they can be stored natively. And then you have things like, I mean, now this is.
I know. So let's assume that, okay, we've been talking about this in a variety of different forms. We have some efficient storage mechanism. Maybe it's quotes native. Maybe it's something which has.
I was gonna answer to your question about dicing and slicing it. So if it is numbers and you want to say, take everything that's larger than something, the thing is stored as a B tree. And so you didn't have to scan the whole thing to get the half that you're interested about, for example. That's so.
What do you mean? But that's in the indices, not in the
indices. Not in the indices. I'm saying if you want to take all people were taller than something, and that something is stored as a number, then you can select them easily.
Why?
Element indices.
That's how it's stored.
I'm sorry?
Element indices in the database sense, Steven.
Yeah, but indices, I mean, the point is that if you want all transactions with your credit card that happen between two dates, there are ways of doing that way more efficiently than going through the whole data set, because it's stored as a tree. And so you can get subparts. That all bets are off when you start storing, and that can work also for strings, for example.
Wait a second.
I've
Databases have an index. Go ahead.
Okay. Do you have to? The question is, if you want to be able to make a query like that and have it be super efficient about, get me the credit card transactions between these two dates, do you kind of have to tell the database when you make it, or at some prior point, like index by date or something?
Yes.
Most definitely. Right. Which is,
but you can't tell it to index by everything is the point, right? You have to make a trade-off.
You could. Your database is going to be larger, but you could tell that you want to construct.
You could make indices across different.
You can do actually a power set of all columns, not just you can index by two columns at a time.
But again, that is okay. So that is content-based finding of things. Okay. So what Rob is doing right now is a data container which is all index gymnastics. Rob doesn't care what is stored at each point. He's just going to deliver it to you based on its indices. Correct, Rob?
Yes. I mean, I care what's stored at each point because that's where the packing will occur. Is for each column will have packing. But besides that, I don't care.
Okay. So now the next issue is, in this data structure, are you doing something where you're, for example, making a tree of values based on the payload values, right? Which you're not doing right now, Rob. But
No.
what people are pointing out is that in a database, it is typical to index by some particular dimension, on some particular dimension, create some particular index, which is an efficient way of storing that content so that you can ask certain kinds of questions of the content. Correct?
Yes.
So typically that content storage is what? It's a tree of some kind, right? Is that right? Because it is something where you're going to have a linear order, as opposed to if it's strings, it's presumably a hash table. Is that correct?
Yeah.
And I think Postgres has stuff for dealing with geo positions and stuff like that too. And
yes.
Sure.
But now,
I mean, to ask a basic question though, I mean, in the version that we're talking about, right? So at the bottom level of Rob's thing is fundamentally something that has the same shape as a single SQL table, right? So I guess the question is though, as we're talking about it right now, that's basically indexed by index. Like it's indexed by the order in which it appears in the expression. Is that right? And we're maybe kind of talking about indexing it by something else, or having some separate index somewhere else that then, lets you basically specify an ordering of the other table that lets you make queries more efficiently. Or
no, I think what Rob is saying is there is the sequence of list indices and keys that get you down to a particular element. That's what he's delivering. Is
right, which is saying that if you ask for the key, 12, dogs, weight, then that refers to index 6,523 in the table,
or whatever it is. Doesn't matter. But he's going to give you the payload that was stored at that index location. Right. So to
speak. I think ultimately I can give you that payload, but also, if you don't specify the large, the column index, it'll give you that entire column at once.
Okay, fine. But be that all as it may, there's a different thing, which is find all dogs that weigh more than 300 pounds or something.
Right.
Okay.
So it sounds like have a mapping.
Yeah.
What?
You could have a mapping. So you could create this table of indices and then look through that table to find the ones that are relevant and then map.
No, I know, but in the database world, it is typical to take that payload and create some data structure like a tree, for example, based on those values. Right.
Well, it sounds like we can do that because we can basically index. I mean, I'm not sure how the user would request it, but I mean, you could index again at the bottom of Rob's data structure, as I understand it. You basically just have, what looks like an SQL database, and you could index it by, the sort of the index in the expression, in the input expression. That might be a confusing way to put it, but but you can also index it by, the weight or the date or whatever you want.
But the point is that in an SQL database, these things all stand more or less on equal footing. So you're also storing the actual, index, like the social security number, as another column. So there is no difference when you want to slice by social security number or by weight. It's really the same thing. Some are can't have duplicates.
We understand. But I mean, the point for our purposes is, we have a structure. We're starting off with something which is like our data set structure, right? It's a hierarchical structure, non-hierarchical.
It's not quite data set, because data set can be very non-rectangular.
Okay, I'm saying a non-ragged data set.
It's not about raggedness, it's about rectangularness. In a data set, you can have a data set where you have an association where you have, the keys people, and then the next key is cars, and under people you have different parameters than under cars.
Yeah.
Okay, it's an outer product rectangularly indexed thing. Okay, but what I'm saying is, in the end, it's, unless I'm completely confused, there is a distinction between the payload and the indices. And what I'm saying is, there are operations like select, for example, that operate on the payload, not on the indices.
Right. I'm confused by what you mean by indice. I mean, because it's like if you have a list, right? If you have a list of strings, of course, the strings in the list are different from the indices, right? I mean, 12 is an index, but foo
I
is a
know,
string.
I know. By indices, I mean our kind of indices. I'm not talking about SQL indices.
Yeah, but why does it have, there has to be a difference between these two things?
Because we have a way to understand it that is based on that. So we're going to go with that way of understanding it. If it turns out implementationally there's no difference, which I do not believe, by the way, which I do not believe at all, then so be it. But the way we're understanding it is we have got something that is, structurally like a data set, except that it's an outer product of indices. So it's a restricted kind of data set. In our data set, we have indices and we have a value. We have keys and we have a value. Does that make sense?
Yeah, but I mean, I guess the question is though, maybe one question is whether it's possible to kind of staple on basically a database that lets you do these queries more efficiently. Because I guess the point matter.
The point is that the conceptual point is, for our purposes, and I don't care how it's implemented right now, for our purposes, we have indices. We have a collection of nested lists and associations, and in the end, there is a value stored. Do we agree? Carlo, do you agree?
Not really, but...
You don't, so why not? It's a data set. What's the difference? A data set has a collection of indices, and at the end, it stores a value.
No, that's not why I disagree. The reason I disagree is that I don't think it makes sense to make the distinction between the indices and the payload. Because the indices
but that's
also have the same
made in our language.
Can I finish my objection, or otherwise I can say
go ahead.
So my objection is that the indices will have the same properties. Will have to be uniform in some sense. You can't have an index that's going to be a mix of positional indexing and string indexing.
Of course.
If they have to be all numbers, right? So yes. They will also have the same columnar structure.
What?
Yes.
Look, there's a slot, okay? Each index, the fourth index is always a string, let's say.
Or always a real number. Or always an integer.
No, we don't have real numbers. We don't have real number indices. We don't have, we can have them in an association.
Well, why not?
Yeah.
I mean,
because we don't have them.
Yeah, we don't have them. We could have them.
No, we do have them in associations.
Yeah, in associations.
Sorry, I think you are confusing indices with keys. So indices are just a few, I, J, K, then indices take values, which are keys, and then for each collection of keys, we have a payload.
Yes.
What I'm saying is that it doesn't make any sense to make this distinction. That you can, since the I, J, K have to be uniform, they behave like the payload.
Okay, but I don't agree with you. Because I think in our language, there is a distinction, right? So yes, in SQL, in relational database theory, there isn't a distinction, okay? That is a fine and general theory that applies to two-dimensional tables, basically.
It's more general than what you're describing, because
I think
you can represent sparse n-dimensional stuff like that.
I think one way of looking into what Carl is saying is that if you try to represent this hierarchical structure in a relational or flat table, then you'll end up with some of the indices being values in that table.
Okay, let's cut.
It seems like maybe just part of the thing here is I think it's just for Rob's thing to work, the sort of table at the bottom that actually contains all the values. All it needs to be able to do is take in a number, which is sort of the number that you get by looking at all the keys that were input and then getting out the value associated with that. And so maybe the point could be that you can index, in addition to sort of indexing by that number, which is basically the position, then you could also index by other things like the values, and then that would just let you do better querying in certain cases. I don't know what the interface with that would possibly look like.
But look. The main point is we're going to have a function that looks at the final value and says, is the final value, and yes, you can do it with relational algebra. You can also do it with the quotes indices, but I'm not considering that case because in our language, for very good reasons, we make a distinction between the way you access the elements of the array and the value of that element of the array. So what I'm asking is, we want to do something where you're selecting by the value of the elements of the array. You want to find those elements of the array for which the value is such and such, or is larger than whatever. And I'm asking, how do we actually do that? And I assume that the way we do it is to use all of the stuff we've built to compile certain kinds of queries to SQL. Is that right? Or is that
You're
stuff
asking
not
how to do
useful?
it better than linear.
Yeah, without scanning everything. We're assuming that it is the case, because it isn't the case. Look, generally, I see. I think the point that Carlo is trying to make is this. Given an index, and I mean index in our sense, and I'm not interested in the SQL sense here. Given an index in our sense, which is, okay, given a set of keys in an association, if those keys, if the thing is a list, it is very straightforward to get the 100th element. You just go to that place in memory, right? If it's an association whose keys are strings, you pretty much know you have to hash that. Am I making sense?
Yes.
If the association happened to have real numbers as its keys, then there is presumably a tree structure, that will get you, or in general, a KD tree type structure, which is what you'd need for geoposition, things like that. There is a tree structure that would allow you to home in on the relevant element for you more efficiently than certainly, but by scanning the things, and hashing won't work for real numbers. Is that what you're getting at?
Yeah. And
Okay.
it's a little bit better than that for strings, because you can say, you want prefixing of strings to be efficient, for example.
Okay. But so what you're proposing here is something that we do not currently have, which is when you index into an association, okay, and you ask for the such and such element of an association. Right now, all we're doing is to do a hash lookup of the index, right? Of the key. Is that correct?
Mm-hmm.
Yes.
Okay. So what you're saying is, in principle, we could have a structure, which we do not have right now, which is the analog of nearest. I mean, we have a structure.
No, it is nearest. The structure exists. It's called nearest function. It just isn't packaged like that.
Right. But what I'm saying is,
and we could have a string prefix function too.
No. But wait a second. If all you're doing is something like nearest, then hashing is the best thing you can do.
Nonsense.
Wait a second. What I'm saying is that if you want, say, you have a billion rows and you want to select some that are within 2 numbers, and you select 1 million of them, that can be done faster than scanning the whole thing.
I think that's what nearest does, though. I mean,
that's what nearest does.
Yeah, I mean, nearest builds a KD tree. I mean, it does, I think, basically the same thing that a database does.
Right.
But,
so, okay.
I mean, this is just a detail.
But I'm the main point, the main semantics that we're interested in is being able to do some kind of select in our sort of multidimensional data container thing, a selection on the values. Am I making sense? On the final stored values. Now, I guess what you're saying is, we don't have, how would you do that? Let's say you have a series of real numbers as indices 3, 4, and 5 in your array.
So not in the values, in the indices.
In the indices, which is not something we do right now. This is not something we do. Maybe
so we're no longer talking about selecting over the values. We're talking about selecting.
Well, I know, but I don't know whether it's even useful. It's not.
Well, I think for the selecting over the values case, maybe to take it first, because I think that is, for the way we do things right now, that is the more common case. I think. Yeah. I mean, certainly you could do something. I mean, if you were just writing in the, certainly you can do stuff already where you do something like, you have your big data structure, and then you put all the weights into a nearest function, and then tell it, okay, when I query the nearest function, I want you to give me back the index in the big data structure. and then, you know, you can do whatever query you want to get all the numbers between X and Y. And then, you know, you get a bunch of indices out and then you query those.
Yeah,
Right? I mean, so maybe.
Yeah. I mean, in some cases, we already do, like, forget about real numbers, but if you're using temporal data, the time series stuff, you are indexing by date, right? So it's not a completely crazy idea that the index
what is
can
the
have
semantics?
meaning.
Right now, the thing we're doing is there are a bunch of indices in our sense that eventually lead you to a record at the end that contains several pieces, you know, name, rank, serial number type, multiple pieces. And the things that you are selecting on are parts of that record, not something at higher level in the indices. They're parts of that record. That's what you do in I think, unless I'm confused.
Well, I mean, the case that Carl, I mean, there's a good case actually, Carl. I mean, like the case of like if you have a time series, when basically you do have an index that has dates as the type, right? So that, I mean, I think most often you are doing the case you are talking about where you're selecting over things that are in the record, but maybe there are cases also where you're selecting things that are not in the record but are in the keys.
And it's really symmetrical. Like you can ask for the days where your time series is larger than something, or you can ask for the Wednesdays.
Look, in relational algebra, there are some things that are easy and there are some things that are hard. We're not doing it that way. If we can make use of the things that makes easy, terrific. But we're not trying to make, you know, we've already got a lot of things that are easy, which are hard in that formulation. So, you know, and it works well. So we're not breaking what we have right now for the sake of some theoretical relational algebra thing. So, I mean, let's come back to what we actually need right now. We need something where it is efficient to go in this out of core structure to do some kind of selection on the out of core structure. That's one thing that we need. And the question is how to achieve that. With the framework that Rob's built, how do we achieve that? Presumably, we have to store an index in the SQL sense at, you know, the value level in the structure. Is that right? Rob?
I don't know.
Okay, well, so
yeah.
How do we do that? You understand the problem. Carlo, do you understand the problem?
I don't.
I'm sorry? Carlo, did you understand? You understand the problem?
I do.
Okay, so what's the answer to that problem? Not a different problem about relational algebra.
So it depends on what the payload is. In some cases, it can be done, and the answer is still doing some kind of tree. If the underlying expression is something opaque, like some kind of, you know, compiled struct.
No, then obviously it can't be done. I know that. I understand that. I'm asking about the case that is the case that you've already just spent 2 years implementing, right? I'm asking, how do we leverage the stuff you've already built for SQL databases for this case?
Well, I mean, we can store it somewhere and then access it quickly. I mean, I don't understand what do you want to know about this?
Okay,
like,
I'm saying we have a data set. Okay, the data set has 1 million rows in it. Each one has masses of, I don't know, hunks of rock in space or something, right? And we want to select, we want to find what is, you know, which hunks of rock weigh more than 5 tons. Okay, which is a query against the payload.
Yeah.
How do we do that efficiently? We've now got a mechanism. We're storing, you know, Rob has provided index translation for, I don't know what, you know, some of those hunks of rock are in Earth orbit, some are in Mars orbit, whatever else. I don't know what. Those are the top level indices. Now we want to know, based on the value, how do we find all hunks of rock larger than 5 tons?
Do you control creating this database and writing to it?
Let's consider 2 cases. Let's consider
because
2 cases.
If you control writing to it and you know that you're going to do the same thing often, then you can use
no, I understand. So you're saying we can build a structure out of core that is optimized for this case. So that's what I listed here. Where did the data come from? It's already in an SQL database, right? Where you may or may not have indexed on that parameter, right? So if it is in an SQL database, then there is presumably a query that you can make. Okay, you're saying if you are creating it, well, I guess one question I'm asking, if you are creating it, what should you create within our framework?
Well, the thing you'll have will be that the intermediate indices that are used in this hierarchical construction will become additional columns in that database on which we will create an index so that the search is fast on them. And the payload will become a column in that same database as well. And then the hierarchical index will be translated into a query that will use those indices to actually extract the payload, the values.
So what you're saying is, if I understand correctly, usually in what Rob is dealing with, you want to get a particular element, and you do that by indexing down with these keys to get to that element. You're saying an alternative thing to do would be to have something which is essentially content indexed, where the content value has been turned into some kind of indexable thing. And how would we represent that? So because normally we are going down to that payload value, how would we represent that?
Yes, but that's Steven, that's exactly the same thing. Imagine that you have payload which contains, for instance, several fields. Could be, I don't know, age.
I get it, but look, what you're saying is we can put essentially a cached index layer as an index in front of, I mean, we normally have, it's this key, this key, this key, this key, very categorical data style, right? You're saying maybe some of that data is not categorical data, it's real numbers, and you can find that, certain operations on it, you can, okay, so what you're saying is that you're doing selection with respect to indices. Whereas what I've been saying is you're doing selection with respect to value. You're saying you kind of pre-compiled some aspects of the value into something that looks like an index, and then you're doing operations on that index.
Yeah, not only index, but also actual database column. Which,
if I understand you correctly, let's say that you have 10 columns of stuff. But one of them, rock size, or what Steven said, is something that you want to be able to search on values.
Yeah.
You compile that into 11th column, that if you make a search based on values, you look up there first and you get what the row numbers are, basically.
Yeah, but you don't need to do a new column for that. That's confusingly called an index in SQL.
Okay. Yeah. Or whatever you call it, but you make an additional data structure.
No, but I understand, but for us, we could imagine that in our data container, one of the things that Rob could be doing is to store an SQL style index, a sort of pre-compiled selection layer for one of his. Let's see, how on earth would that work?
Well, actually,
I mean, this mirrors a lot what we have been doing in other areas. Many of the times when we implement fast operations, we have to build a data structure that gives us fast operation.
Right.
Okay. Right. And this is just a more generic, sounds like a more.
I don't think it's that generic. I think it's actually rather ungeneric, because the number of operations that can be done against, for example, a collection of real numbers isn't that great.
No, I don't think so either.
It's various things about, greater than, maximum, whatever else. Right. Which happen to be the things which, as I understand it, Carlo and friends have just built the whole mechanism to compile into SQL. Am I confused somehow?
No, that's right. But it can be combined with other things. As I mentioned on a different meeting, for certain specific SQL backends which are in process, such as SQLite or DuckDB, they allow callbacks to the kernel, which may allow you
Okay,
to
I
perform
get it.
vastly
I get it.
more.
I get it. I get it. And with the compiler, that becomes more interesting because you can have a
Yes.
compiled callback. Okay, but the basic point is that the thing that you are describing is in the data container, you could specify. See, the question is the API for the data container. One thing that you can do is just extract elements using quotes indices, our sense of index. See what I'm saying? That's one thing you can do. Now we're saying you can also make a slice that is not based on our indices, but is based on some aspect of our values. Am I right?
Yes.
Yeah.
Okay. All right. So now the question is, what does it look like when you do that? So you say data container, and the data container is, in Dataset, you would be saying, well, I mean, you'd be doing a select with some function.
Stephen, at least my picture is this. You simply store the intermediate indices in this hierarchical structure as extra columns in your SQL database, if you mean SQL way of doing things. And then once you do selection over the values, you extract back both the values and basically all those rows which contain those indices,
I get
which
it.
allow you to reconstruct back your.
Yes, I get it. What I'm asking you is, okay, in a data set right now, for example, what we have is a series of levels, indices, whatever you want to call them, dimensions, defined by the user or coming from wherever the data came from. Okay, we haven't added extra levels. We haven't added an extra quotes SQL style indexing level, right? So we could certainly imagine doing that. I want to know what the semantics we imagine for that are, because for data container, there's very obvious semantics for extracting an element, which will be the same semantics as for extracting an element of a data set. That is, you just give, open bracket, index 1, index, comma, index 2, comma, index 3, and so on, right? But those are genuine indices, not these value created indices. Am I making sense?
Yeah, so basically you're asking what to do if you don't have this structure ready, but instead you just have the data set hierarchical as is, and you want to know how to do this.
No, I want to know, what does it look like in the data container if what there will be is certain operations that you can do on the data container that are essentially compilable into whatever the, for example, into some SQL thing that can be operated against the sequence of real numbers that exist as keys at one level in the hierarchy, right? That's a typical type of thing.
So what you want to know is like, how would I tell a data set, please make the access to this column fast?
It's not a column. It's not a column. It's just values. I mean, yes, they are in a column. So how do I make this? Okay, we have defined essentially a location, a class of locations. We've defined a path effectively to a certain thing. We say all the things that you access on this path, I want to do operations by value for things on this path. That makes sense?
Yeah.
Okay, so now how do we set that up?
So you are effectively asking about the generalization of a sparse array with keys, which can be also strings and whatnot.
No, I'm not. No, I'm not. No, I'm saying there is a way to there's a path that gets you down to values which are masses of rock, let's say. Okay, and then what I'm asking is, if I want to do a select based on the mass of the rock, okay, I want to have pre-created a tree that represents all those different masses of rock, so I can quickly tell you all the ones more than 5 tons and less than 7 tons or something. Am I making sense? Right, but it's a thing based on value. It has nothing to do with our kind of indices.
So you're saying make this fast. From now on, whenever I ask about rock masses, I want that to be much faster.
But the question is, what does that look like in because we're not creating one of our style of indices to represent I mean, at least
Of
that
course
isn't
not.
current
It would be
idea.
hidden or something like that, right? It's like
Probably,
an extra metadata.
probably.
Yeah.
Maybe it shouldn't be hidden. I don't know. But the point about it is we're trying to say, but then what is the access in the data container? It would say something like it does in a data set, which is select, hash of 1, 2, 3, mass, select those things greater than 5, less than 7 or something.
Right. So I think that one way of approaching this would have been to store things internally as a sort of a flat value list on which you can select and have some kind of index built on for them, but then have a mapping between those flat positions and the hierarchical positions that are in the actual data set. And that's where I think Rob's work could kind of kick in.
Yeah,
no, but
I'm still trying to asking about the interface to it.
Yeah, what does it look like? What does it look like when you're asking, here in the selection function, you have a data container and you're asking for, what are you asking for? You're asking for select hash 1, 2, 3 mass, greater than 5, let's say. Or actually, I mean, is that what it looks like? And then the question is, how do you pre-tell it, I want queries like that to be fast? Do you see what I'm saying?
Yeah. So that would be the equivalent of what is called create index in SQL. So make this access to this column fast.
I understand.
Yeah.
I understand.
So you want to know how we tell DC modify yourself so that this becomes fast, right?
For example, yes. Or alternatively, it could be the case that we actually want some form of, fake index that is just this thing. Fake index in our sense that is this thing. I don't know.
The thing is that if you start considering all of them on equal footing, then select, position, and then also part, extract, etc., are all pretty much the same operation. Mm-hmm. And so if you optimize one, you optimize all of them.
No, you don't. No, you don't. Because the whole point is to optimize greater than 5. Right? You're not just optimizing. Part extraction is just delivering a value. That requires no backend computation. Any backend that we'll ever consider using for anything can deliver, here's the value from that place.
Well, it depends on...
Not necessarily, right? I mean,
not necessarily, but as a practical matter, everything we've considered can do that. But it is not the case that everything we've considered can return, the arctangent of the mass is greater than 5 pi or something.
So can I make an example? Suppose you weigh yourself every day and you have a data set, which is basically the dates and your weight. So if you say this is weights indexed by dates, then getting the weight you were on yesterday is a part extraction thing, right?
It's not part extraction because dates are a more complicated thing to extract from.
But
like
why wouldn't you? Sometimes you have data sets that are indexed by dates.
For goodness sake, the issue is this. There are certain operations that backends can natively deal with. For example, finding something that is in a certain range, dealing with basic order relations and things on the real line. They can deal with that. If I start feeding you more complicated functions, they will not be able to deal with them. And some backends will be able to deal with some functions, some will not be able to deal with those functions. The question is, it could be the case that things which are essentially range and interval queries are totally different from every other query. Could be the case. I doubt it. See what I'm saying? That's different from, the greater than query is different from the nearest to query is different from, but these are all queries that are stories of the real line, basically. Now, is what you're saying that, but our language does not particularly have semantics that distinguishes those kinds of queries from arbitrary select with all kinds of criteria queries that have nothing to do with specifically just orders, sort of things about the real line. Does that make sense?
Mm-hmm.
Right. So
I think that in real data, the point is that you never ask for like part 47 because you don't know what it is. So you are always asking for something like yesterday or user 94.
Right. Or if you've optimized, right? If you've added the tagging you need to optimize, the mass greater than 5 query, then you can ask for the first 5 of those very easily, right? So
right, but
you've made position, right? So if we create this sort of meta index we've talked about, right, that would be mass greater than 5, 3 to get the third one in the database or whatever.
No doubt, but the main point that you're making here is, given something which is in the values as far as we're concerned, there is the possibility of making that essentially a faux additional index that could be used. So in other words, for data container, normally you go down, you say, select this part of this part of this part of this part, right? What this is saying is there is a different index path that you could use to get to those elements. In other words, so look, at the final level, right? At, where is it? We have here, at this level, either index by position in the level, or have a different index, different indexing scheme based on some aspect of value. Is that right?
A really nice thing in R and these things is that you basically treat that thing that you call mass there, which is kind of like a key, right? In your case, Stephen, the mass is a key.
Yes.
Is to think of that. So that's a column or generalized column.
Yeah.
But one thing is to think of that as a variable. So you could just say mass greater than 5. Do you see what I'm saying?
No, I don't understand what you're talking about.
But that's precisely what I was talking about earlier. When you
isn't that just the SQL indexing by another column, isn't it?
You convert the index into a column value, and you store additional indices as just additional columns in the database.
Look, what I'm saying is this: okay, let's say that we have an array A. Okay,
I'm not disagreeing with what you were saying, Stephen. I was thinking this is another.
Okay, I think you've got an array A, and it has its final. Let's just do a one-dimensional array. We don't even need to do these higher dimensional arrays. Element 3, 4, 5 of that array. Okay, we can extract that element. The element is 67, let's say. Okay, an alternative thing that we might want to do is to say we have created some kind of index of the values here, and what we want to do here is select hash greater than 5 or something. Okay, this being based on the we have certain operations, but this being based on the index of values. Do you get what I'm saying here?
Yeah.
It's an alternative indexing scheme for A based on the values. Now, my question is, it's probably the case. How to think about this? I mean,
one way to think about that is a mask for that column, for that value. You know what I'm saying?
Yeah.
Like all the indexes in our meaning of indices.
It's just like we would say.
Yes. Yeah, exactly.
14 or something.
Right.
Yeah, that, or you could say A open bracket hash mass greater than 5. But that's still a part, like a span.
Well, but it isn't. Hash mass would be, look, hash is the value, is the payload, let's say. Look, okay, so let's say, let's say we said something like this. Value index to func, which is maybe more than you need to say, but let's imagine we did that. Let's imagine we had a thing that said that. Now, clearly, if we had multiple...
Isn't that a variant of position? Like you want the position by predicate, right?
Yes, but the whole point is you can't do, for example, value indexed of func on 2 indices. You can only do it on 1 index ever.
Why?
Because it doesn't mean anything in this case. You're picking up, this is saying, okay, this case is perfectly meaningful. You go down here, you select only that subslice. Within that subslice, you value index.
No, but I'm asking, like, you could in principle say, I want to know who are the people who are taller than something and heavier than something.
Nope. You never need more than one of them. You never need more than one, because this function, by the time it's looking at the value, those different elements, height and weight and so on, those are parts of the value. They're parts of the value, right? Remember, in our setup, you've got the array A. It has a bunch of indices in our sense, and then it has a value. That value could itself be something that has, be an association, for example. Right? Am I making sense? But it's a separate value. It's not something where, I mean, maybe you're making a different point. I think the point you're making is not right, but the point, it is the case that you obviously might want to select. So here, see, remember, these are not different hierarchical levels. These are within one level. You see what I'm saying?
Yeah, but I'm just saying that if you consider the sparse version of that, then you don't care about the levels.
No, but you do care here about the levels. We're talking about the levels. Data container is for rectangularized arrays that are not sparse. That's what we're talking about here. If we're talking about sparse arrays, we're in a different area. That's a different thing. We're talking about rectangularized arrays. That's
what I'm trying to say is that sparse 2D things, and by 2D, the second D is that you can have both height and weight and then phone number.
That's not the same dimension. That's not the same meaning.
It's not the same. No, it's
not the same meaning.
Let me finish. What I'm saying is that if you index sparsely into association,
we're not talking about sparse index.
Okay, let's not talk
about
what
we're talking about. That's not what we were talking about. This whole meeting is about dense rectangularized arrays. Am I correct? We're not talking about the sparse case.
I don't think he's saying the data is sparse. I think you're creating a sparse slice. Am I correct, Carlo?
No. What I'm saying is that you're making the distinction in order to get to this thing the way you are thinking about it. You're making a distinction that is quite artificial, and that you can store arbitrarily deep in the sense of indices things by just thinking about them as 2D sparse things, that they are equivalent algebraically. You just need to drop the distinction between values and indices.
But we don't drop that distinction. Our language is based on indices, values. Okay? We could have designed it differently, but we didn't. And there's good reasons why we did it the way we did it. So that's what we're going from. We're not changing that. We're trying to understand how do we make use of what we can make use of from these other ideas. We're not saying we're changing that so nobody understands anything.
Right. It's the transducer, Stephen. You don't have to change anything.
Exactly.
That's the whole point of designing this thing. Like then people will use select, they will use position, they will use things that are familiar to them, but it doesn't need to be like that all the way down. That's all I'm saying.
So
okay, does anybody else understand this?
Yes. Okay. Let me explain how I see this, Stephen. We are designing this rather opaque structure, which is this scaffolded array. So we allow certain translation layer in between. Isn't that the whole business?
Yes, that is the whole point.
So that is exactly the layer that is supposed to be a translation layer between how it looks from the outside, which is hierarchical indices, and how it may be stored inside, which, for instance, can be a flat table with those indices becoming new columns. Just as
whatever. That's fine. What I'm saying is, what is the semantics? What does it look like? What we would be doing here. Okay, we need some way of saying, I want these particular elements of this array. We have that in Dataset.
Yeah, I mean, you can just put all, all up to the last layer, which is the bottom one where the values sit.
Yes, but you can't do this. You can't do this. This is the point I was making. You can't do this. You can't expect that to work. There is only one place you can index by value.
It's like position. It's like position.
Yeah,
you know, select gives you the actual values, right? But position gives you the actual sort of indices.
I understand, but what this is doing is it's saying one of the indices here is going to be based on the value, not based on the path.
Yeah.
Okay, so but only one. You can't have two.
But you don't
cannot have two.
You don't need to. You don't need to.
Okay, that's fine. But Carlo is saying you could have two, and I think it's just wrong. Okay, because what's happening is I'm trying to understand. This can only be a path. Because
I don't know. I'm not sure what you mean by the value, right? Because if we have height and we have weight, what is the value that we're getting into? Is that like my name? Like what is the value? Maybe we're not agreeing on what the example actually is, which is why we're disagreeing about.
Well, it's this thing here. Okay, so we have a whole list of height and weight values.
Right. Okay. So you're saying we have two values. So why can't we index on two values? Give me all entries which have height greater than 5 and weight greater than 7.
Okay, what's the syntax for that? Those are not two different levels. They're at the same level.
Right.
They're always at the same level because the thing.
Right. So if you really had a bunch of associations like this, right? You would do pound height greater than whatever and pound weight greater than whatever.
Yes. That's what I'm saying.
But suppose you wanted to do it by body mass index, you'd have to combine height and weight.
Yes, right. So that's what you're doing in this value index thing.
Yeah.
That's exactly what you're doing. The thing that I'm saying is,
I mean, still, why do we even consider an index as a kind of headdresser? Why can't we add it as a part of this data set as a metadata? You then can have as many indices as you want.
Because you can't. This value, the values are at the end. You see what I'm saying? The values are at the end. You go index, 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 value. This is something being computed on the values.
Yes, right. But then the question is, what, as previously Roger was saying, or Itai was saying, what we consider a value. In some cases, the value can be.
You are getting confused because you are considering this case where you could have an intermediate index that is something that has operations doable on it, other than just matching it. That's the case you're considering, which is a case we have not otherwise considered, except the nearest.
Steven, okay, maybe I'm misunderstanding. I don't understand why value index, if value index is like position, why doesn't it give you the full set of, if I ask you, who are the things at the leaves of this big tensor that have height and weight larger than something, why is this not returning the whole sequence of the position? Why just one index? It's returning all of them.
It returns one index. Yes, it returns all of them.
Always all of them. So you don't do like 5 to 1 and then value indexed, really.
Yeah,
No,
maybe this is the confusing thing.
Right.
Why do you want to specify the 5 to 1 before?
Because it's saying within that subslice, I want the things where this is greater than 7 or something. See what I'm saying? within that subslice.
Yeah, but wouldn't that like
Carlos saying, and you know, you want to separate that subslice in the higher indices from the subslice in the lower indices. They don't need to be the same function.
No, that's not what I'm saying.
No,
What I'm
it's
saying
not
is
what
that
he's
imagine
saying.
that
No, it's not
imagine
what he's
that
saying.
that subslice is like, imagine you have a first index that's like department and it's a string, and then you have a second index that's just a, you know, the third person in that thing. So in general, if you want to say just give me the people in the ECE group and their weight and height, why wouldn't you also put that in the select, really, and say, you know, select people from
Here's where
ECE.
you're-
I think this is what Stephen means. So I think that the pre-index, the 521, you could think of them as spans, for instance. You know, and the only thing that does is select a subarray.
Yes, that's right.
Okay.
Yes, I should have said that was a span. There could have been an all
Right.
there.
Right.
Yeah, fine.
Okay, so that's a span. So now we're looking at sort of the last thing, which is our generalized column. Now, find me everything in that last piece, you know, in that generalized columns, basically, columns that satisfy the condition.
Let's make this, I mean, I want to see this. Let's say that this is like, the first thing is like, we're talking about an army, and the first thing is like army, and the second one is Navy, and then Air Force. The first index tells you which part of the, you know, the generalized army this is, and then you have corps or whatnot, and then you have platoons. I'm trying to think of a hierarchy of people there.
I
Sure.
think that Steven is just asking for something more general.
My question is
put
that-
a database in a matrix, and then you still want to be able to use a matrix indexes to find.
Yeah, but what I'm saying is that these things, like if you have effectively a matrix of, you know, platoons and armies and corps and whatnot, why, when you're asking this stuff, wouldn't you put it all in the same place as a big select statement, instead of making this gymnastics here, mixing indices?
Oh, I see. That's a syntax thing.
Yeah.
Oh, but that's just
also
a different...
like a thought process thing. Like why would you want to think in terms of like 521 and then ask for what you want, and not just ask for what you want?
Yeah, I know. I agree. That's what I said at the beginning.
But by the way, I mean, this is closely related to some of the syntax of like query and dataset,
Indeed.
like where you can put a select in the middle of it.
Indeed. This is a yet different case that Carlo has been implicitly talking about, which is the case where the indices, the keys of an association, are something like real numbers. And what we have done in selecting pieces of an association, the most obvious way to do it is directly by, I mean, it's not very common. We could do it. You could do it, you know, we don't do a nearest key of an association.
Maybe associations aren't really the right thing for that, though. I mean, maybe there should be a different, you know, because the point of associations is they're like hash maps, right? I mean, they're like hash tables.
Yeah.
So I think that this is something where, I mean,
well, arguably,
the mental model is that
it's 6.
I think the mental model is that lists are like arrays, associations are like hash tables, and maybe it makes sense to have some other thing which would be useful for dates, certainly, and maybe other real value things. That's like a, you know, some sort of binary tree or something, or KD tree,
or more like it. I'm just thinking of like, let's transpose this thing around and say that this thing is a list of associations that contain height, weight, and then first index.
No, you're getting confused.
Third index.
No, you're getting confused again. The point that Christopher is making, which is one of about 6 points that you seem to be making, Carlo, is that there is a different case that we do not currently have, which is a structure that is a real number maps to value. I mean, we have that in interpolating function. We have it in a bunch of different places, but we don't have, and we have it in nearest function and so on. It is somewhat related to what we have, the notion of lists and associations, but it is neither a list nor an association. It's something slightly different. That we have a bunch of operations for dealing with, but we don't have kind of a single native type. And it could be that our sort of interfacing to databases is, precisely the thing that makes, you understand what I'm saying, that's convenient when you're interfacing to databases to have such an object. We need to wrap up for today. I'm a little frustrated that I feel like we're, this particular issue of, these things, operations within a data container, selection operations, we haven't even talked about aggregation operations, how we specify those, and then how different backends work with those. Because I think we did talk a bit about how the pure select an element based on indices of our kind, right? We explained how that might work for things that are backed by files, databases, whatever else. What we're now talking about is how things that select elements by value might work. And then we need to talk about how things that aggregate values might work. Am I making sense?
Yeah, well, I think what we really need is, a few more concrete examples, like actual, even, right, not actual complete data sets, but sort of little pictures of here's what my keys look like, and here are the operations I want, and here's what I want.
Right.
I think we've stayed too abstract.
Yeah,
and we're not all agreeing on what we mean as a result.
Yeah, well, fine. So let's get that for next time. But then what we want, the purpose of this was to talk about, again, we have to be very clear on this. Where did the data come from? Right? And which of these options here are things where you realistically got it from somewhere else? Making sense?
Mm-hmm.
Yeah. Another thing I would add for next time, and I'll do the homework on my part, I think it's very useful to have examples of what we have in mind, just to dispel any doubt, but also examples of how we think we can use it, like how you the machine learning pipeline is going to use this. This is putting some not only constraints on the design, but pointers that might help making the discussion more concrete.
Right. Sounds good. All right, let's wrap it up. I mean, if we're able to do one of these soon, I don't know whether everybody's dispersing. But if we're able to do another one of these before the end of the year, it'd be nice. I don't know. We'll have to see. Because I feel like the longer we leave it, the more confused we're going to be the next time we start up. But I think we've got a definite path that involves finding some examples, etc. And it's great to hear that Rob is on his way to implementing the thing we've, the non. And Rob, does it make sense to you? You're implementing things other than these things. Is that correct?
Right. Yeah. No. I'm implementing a prototype of an idea, which I'll call data container, and it'll have a certain API, and then we'll have to see if it's flexible enough to work for these other cases that people are talking about.
Right. It will need these cases, but right now all it is it is extracting slices, elements or slices of elements purely by index in our sense of index.
Yes, precisely. So that's what I mean. So don't be disappointed if it doesn't have anything more than that. So.
No, that's already very useful to be able to do that, and it will reduce the storage needs by some huge factor.
Yes.
And then we have to understand for what you want there, which is already very useful, how can we back that with things other than in core stuff?
Right, precisely.
Aggregation at the column level, because of the way things are represented, is usually clean.
Right, but it may be that there are some pre-aggregates that we can store, which is sort of the promise which I don't think is realized in OLAP, and is the thing that we've thought about multiple times over the last decade, that we've thought about, how do we store data so that a bunch of it is pre-aggregated, so that, I think someone had used the example, you don't want to ever get this weird slice of the data. You want to get slices that are easy to describe. So this is a pre-aggregation, just like we've described elsewhere, a pre-indexing, a pre-treeification. This is another kind of treeification-like operation that is a sort of cached summarization of slices of the data that you are likely to ask for. Did that make sense?
Yeah.
I mean, it's very similar in spirit to things like the prefetching of entity slices and so on. It's all the same type of thing of what are you likely to ask for together, and sometimes with some kinds of data, it's very hard to know that. And other cases, it's rather obvious what, you'll want to ask for the average weather in a month, not the average weather in a very bizarrely aligned month, so to speak. Make sense?
Mm-hmm.
Okay, good stuff. All right, thanks, guys, and see you later. Thanks to folks on the live stream as well. Oh, somebody was asking, okay, one question here. Somebody was asking, why are we not using HSQLDB? I don't know what that is.
No,
HSQLDB. HSQLDB.
I think it's a memory database, which has a rather limited scope of applicability.
But it probably should be on our list here.
Actually,
yeah,
yes.
and we actually bundle that with database link, right? I mean, it's a pure Java file-based database, right? And I think we actually bundle that with database link.
Yeah, I will add it to the list as well as HDF.
Sounds good. All right. See you guys. See you guys later.